Hello and welcome to another video about Rust and web APIs. Today we are going to talk about various aspects of the new version of the Axum web framework, Axum 0.6. It changed quite a bit in the area of shared state management, and this is what we are going to dive into. But this is not the only part of this video. In my Rust trainings that I do with people on various occasions, I often see that especially Rust beginners struggle with traits and trait objects. And traits and trait objects are super important when it comes to Axum and state management, because what you typically want to do is that you would like to isolate your, for instance, let's say data access layer from your web API handlers, and this is typically done with traits and trait objects. You would like to use dependency injection so you can use a real implementation of your data access layer during runtime and a mock object during testing, and this is exactly what we are going to take a look at today. So we are going to build a sample web API with Rust and Axum 0.6. I will walk you through some changes that happened in the latest version of Axum, and then we are going to further develop that step by step towards a solution that uses dependency injection, traits and trait objects to decouple lower layers of your application like data access from your API handlers, and we are going to write unit tests that really are able to isolate our API handlers with the traits and trait objects that I just mentioned. So let's get started. Before we dive right into the code, and I have already here my Visual Studio Code open, let me tell you that I'm going to copy and paste some code parts from a sample that I created for exactly that video and an article that I've recently written. And maybe some of you would be interested in the entire code. You don't want to follow along typing all these things. That's perfectly fine. I will link the sample code, which is on GitHub below this video in the description field. So if you would like to see the entire source code, just grab this link, open it up, and get the software from there. Okay? Good. And with that, let's get started. The first thing that I would like to do is I would like to create the data access layer of our small little application. And for that, I have prepared a little bit for you. First, we need a modal that represents the data that we are going to store in the database. I'm going to simulate a database. We're not really using a database. That's out of scope of this video. But the modal, you see it here. It's a hero. We maintain superheroes, and each hero for brevity has ID and name, and that's it. Please use your imagination if you would like to have a more complicated modal. That's not the topic of this video. The next thing is that we need to implement a repository. Here, let's put that one here. Here we have this heroes repository. We are going to use this hero repository and add some functions which simulate the data access. In our simple example, we are just creating a sample data access function which says get hero by name or get heroes by name actually. And that's it. All the other data access functions like adding and updating and doing more complicated stuff on the database, they follow the same pattern. So I think it's okay if we just add one and you can fill in the blanks for your concrete domain and for your application. Now let's implement this hero repository, and I have prepared the code. I will walk you through this code in a second, you see. Here we have the code. This is our heroes repository, and our heroes repository has one particularly interesting function. It's called get by name. This function will get heroes by name, so we can add a name filter here. I told you that we are not really using a database, so I'm just using a const array of heroes here in my sample application. But still, we are ready for a real database. So as you can see here, I'm using Tokyo's time sleep functionality with a wait here at the end. So we are really doing async programming here. And of course, you can fill in your favorite data access component like SQLX or any ORM that sits on top of SQLX or whatever fits your need, you can add it here. The important thing is that this thing is really fully async. So you can add whatever you want in terms of async programming here. Now, as we don't have a database, we need to do the filtering of the heroes by hand, but that is not really a problem. The only specialty that is noteworthy in this implementation is that I take the name, this is the filter that we got into this getByName method, and we are stripping a suffix of a percentage. Percentage is a wildcard, so if a wildcard is at the end, we are filtering with starts with. If there is no wildcard at the end, we are filtering with equal. So this is a business logic that is built into our, quote, database, okay? At the end, we simply check whether we have found some heroes. If we haven't found some heroes, we will return not found. It will be the task of our web API later on to turn these data access errors into proper HTTP response messages. And we will take a look at that because that is exactly what we are going to test. And if we find heroes, we will return OK. So this is our data access logic. And to get rid of all these warnings, let me go up here and say here, allow unused that code, sorry. That should be fine. And with that, the warnings go away. Oh, what did I do wrong? Allow that code. Oh, I have to put it up here. Zip, and now it's good. Now it's good. Now we are good. Now we don't have any warnings anymore, and I can develop this solution step by step. So let's summarize what we have done so far. What we have achieved is that we have, let's say, a data access layer with heroes, with a repository, and an implementation with one data access functionality, getByName. Fine. That's good, sounds good, looks good, let's continue. Now that we have our data access layer, we can start to implement our API handler function. Let's do that. Of course, I have prepared this API handler function, and I will do another code walkthrough for you in a second. Before we do that, let's add here a little helper. It's here. It's a type alias, just to make our life a little bit easier when it comes to programming with Axum and shared state. I just created a type alias for an arc version of our repository. Arc, as you know, the atomic ref counter is very handy. It's necessary when you want to do shared state because we need ref counting and we need thread safe ref counting. And I'm bored of always writing arc of something, so I created a type alias. That's the only thing here. Now the API handler function itself, you can see it here. It's called getHeroes, and this is one of the new things that you see here that came with Axum 0.6. It's the state extractor, as you can see it here. This state extractor has the huge difference to prior versions of Axum that it is type safe, and you will see in a second what I mean with type safe. For now, it works very similar to the extension extractor that we had so far. It just extracts the shared state from our routing and app infrastructure that we will build in a second, okay? So this getHero gets access to the shared hero repository through the state extractor. It also gets a filter with the query extractor. So we get the name filter of the hero in a query string parameter. Then we do a little bit of logic, and this logic is particularly important for our demo here because we would like to test exactly the behavior of that API. And later on, when we add the trait objects to our implementation, we want to isolate testing of this API. So we want to be able to test this API without the real data access layer. Currently, we are bound to the data access layer heroes repository because this is exactly the state that we depend on. We cannot inject anything else. We need heroes repository, otherwise getHeroes will not work and Axum will not compile our code because of the new type safety feature in Axum 0.6. Okay, that's the point. But bear with me, we will replace this guy with a trait object later on. So let's quickly go through the code here. It's essentially pretty simple. If we don't have a name provided, we use the percentage wildcard as a default value. If there is no percentage at the end already. We push a percentage because we always want, that's part of our API logic, we always want to filter with starts with. So that is part of the logic of our API that we have to check later on. Then we call the data access layer, a method that you have seen before. And finally, we have a little bit of business logic that turns the result that we got back from the database into HTTP response messages. I kept it simple here, so I took just a status code, turn it into a response not found if we didn't find a hero that fits to the filter string. We return the heroes as JSON if everything is okay, and in all other cases, any technical error in the connection with the database, for instance, we simply return an internal server error. I consciously kept everything very simple here, so no specific logging and things like that. That would be the topic of a different video on a different day, but today this is out of scope of our sample. So, looks good, doesn't it? We have our API handler function. And now that we have the API handler function, we can go over spinning up our server. So let's scroll up directly here to the main method. And of course, we would like to make it nice and structured. So what I'm going to add before we are spinning up the server is I'm adding a helper function here. I called it heroes routes, and it can set up all the heroes related API handler and routes in a single spot. I really like to structure the code like that because with that I can have all my hero related stuff in one place, and typically APIs that I build are rather large, so I can have multiple of these helper methods and they set up all the API endpoints for the certain domains, for the domains that they are responsible for. The important thing here, and this is now really important, the important thing here is, oh sorry, I did a wrong zooming here, now it's okay, is that we return a router of heroes repository state. And this is important. This has now changed with Axum 0.6. We must return a router of heroes repository state because we have a handler that requires a state extractor that needs heroes repository state. We need that one, otherwise it wouldn't compile. If I would here return a router of another type, Axum would not compile. If I made a mistake and I used the state extractor in get heroes in this method here with a different type, I get a compile error. I do not get a runtime error. I get a compile error because the whole stuff is type safe. You can compile it and it complains at compile time. Super nice extension to Axum here. Now, last but not least, we need to set up the server, and that one should be pretty simple. Here we are. Let's format our code and let's add a Tokyo async main in order to make everything running. That will be an async func main, and with that we are fine. We are creating our repository. In real world, this code would be a little bit more complicated because you probably need to connect to a database. You need to do with database connection pools and things like that. But in our example, we are not focusing on the database. We just want to have conceptually a data access layer. And this is exactly what you see here. As I mentioned before, we are now tightly bound. The web API handler is tightly bound to the implementation of the heroes repository. So this is not our final goal, it's just an intermediate step. Now the router itself, it's pretty simple. We are setting up a new router, and here we nest the heroes routes. This is the helper method down here under the /heroes route, as you can see it here. And now comes the important thing, with state repo. And here you see this repo is the heroes repository, and with that we are end-to-end type safe. If we would forget the with state here, we couldn't compile it. It would not work anymore because, yeah, we have type errors here, see? So we have to add the with state, otherwise it simply doesn't work. Super important and super nice extension. And finally, our code is ready. We set up the server, we run everything. Want to try it? Let's try it. Cargo run. While this is running, let me copy in some requests here. Let's create a requests HTTP I'm using a plugin of Visual Studio Code, which is called the REST client. I'm sorry. It's super useful and super handy when you would like to do some quick and dirty HTTP requests. And while I have set up this little demo here and this little sample requests, my computer should have been able to compile our entire application. So I think that's it. Yes, we are running. Let's run the heroes here, and you see we get Wonder Woman and Deadpool. If we specify a request, Wonder Woman can be found. If we specify a wildcard at the end, it works perfectly fine. If we specify a name that does not exist, like Spider-Man, we get a 404 not found. This is exactly what I wanted to show you. Our app works perfectly fine. Nice. Of course, we don't want to do the testing manually, obviously not. So we want to add a little bit of unit testing, and I've prepared a little bit of unit testing for you. Let's check it out, and here we will see the difficulties or the problems in our solution. I will lead you through the code here, okay? Now, what you see here is just a request builder. We are building a request, an HTTP request to a certain given URI. To keep everything simple, we just do get requests because we only implemented get heroes. We send an empty body, obviously, and that's it. That's just a helper function. Okay, let's fold it up because it's not that interesting. Then we create a data-driven test using rstest. I like to use rstest for this purpose. It's really nice, and it allows me to very easily set up data-driven tests. So you see here we are passing in different URLs, and then we can try these URLs with our server. What we essentially do is we create the hero repository, and exactly here we have a problem. This here is a problem because we are now instantiating our repository, which is the data access layer, directly in our testing code. So our testing code is tightly bound to our real implementation of the database, and that is exactly what we do not want. But it works. At the end of the day, if you want to have an integration test that really fires SQL statements against the database, hey, feel free to do it. Party on. It works. We can simply use the hero routes. That's the helper method that we created before. Provide the state here directly in the test. We can do the proper request. This is the helper method that builds the HTTP request that you saw up there. Then you can check the status code, as you can see here. You can download the HTTP body, and in this case, I'm just verifying that I get back an array. Well, in real world, you would probably have, in such cases, a well-defined database, a test database where you know exactly what's the content of the database, and then you can implement a more intelligent testing here for real data. But at the end of the day, that's your job, and that is not the part of this video. Now let's go down a little further. Here I'm testing a failure. So if I send something from which I know that my test data doesn't have any knowledge about, I expect that the web API returns not found. So it should correctly translate the database error not found into an HTTP status code not found. Unfortunately, we cannot simulate anything else regarding technical errors or technical problems because we cannot simulate a crash of the database, for instance, because we are connected to a real database, and it's pretty hard to simulate something like that in an integration test. But hey, let's give it a try. It's a start, and we have somewhere. So let's compile it. Let's compile the tests. Let's run it here. And it should come up in a second, and hopefully we will get some okay responses from Rust here. Building is nearly done, and here we are 4 times. Okay, nice, we got it. So now, let's tackle the problem of this tight binding between our API handler function and our data access layer. What we need in the middle is, let me switch to my notes here. What we need in the middle is a trait. We need to change our data access layer that you saw here with the repository. We need to change that and use a trait here. So let's create a proper trait that we can use for our data access layer. Let's do that. Such a trait could look like that. So what I essentially did is I took the getByName function and I moved it up from the heroes repository into a trait. And I would also like to point out, let me zoom in, that I used the crate mockall, which I really like to use. And mockall provides a macro which is called automock, and this automock macro will automatically create a mock structure called mock heroes repository trait. So they will just add a prefix here, which is called mock, and I will be able to use this mock object later on in my unit tests. Very useful. So as you see, automock saves me a lot of work when writing unit tests. But for now, let's focus on the implementation, and then in the second step, we will take a look at the unit testing. So now we have a trait. So obviously, we need to implement this trait. So here, instead of impl heroes repository, we are going to say impl hero repository trait for. So we are simply moving our implementation from the struct into the heroes repository trait, as you can see it here. Now, what we also need is we need the async trait here, because we are using async in a trait implementation. So therefore, we need to move down the async trait macro in order to get rid of the compiler errors. But did you see I didn't change anything else? I'm just introducing a trait which abstracts away the data access methods, and now I can build my API functions on top of the trait instead directly on the struct. That is the whole idea here, okay? So remember this trait, we will need it in a second. Let's see how we can use that here in the getHeroes handler function. The tricky thing is that we now need a trait object and not just the trait. What is a trait object? A trait object is the possibility, it's a kind of polymorphism. So what a trait object is, it is a real object in memory which has a reference to the object that implements your trait, and in addition to that, it has a table of all the functions which are implemented in the trait. So it uses this function table to do dynamic method dispatching at runtime. It's not static method dispatching, where the compiler knows exactly which method is called at runtime. It is dynamic. Dynamic is important here because at runtime, we need to call the real implementation of our getByName function. And at test time, we need to call a mock version of the getByName function. That's the whole thing why we are doing all that. So this is the reason why we need a trait object. And let me show you how you can get such a trait object. I created it for you. It looks like that. The important keyword here is the din keyword, as you can see it here. This is the din keyword, and here is exactly the trait that we created a second ago. This is the heroes repository trait. Now this send and sync here at the end, you need it because we do async programming. Please consult the Tokyo documentation to understand more about send and sync if you are not familiar with these traits. I am not going to dive into details about that because this video has another content here. Okay, so this is our trait object. Our trait object. This is the din here, or it leads to the creation of trait objects. That would be more exact. Now inside of our getHeroes, we now need to switch from the hero repository to the din heroes repository. That's the important thing. I switch that one up and I give it the din hero repository. See, the code down here works perfectly fine. The problem that we get is up there because of the new type safety functionality and the state extractor that I introduced a few minutes ago. We need to change everything to the correct implementation or to the correct type. And we need here that dynamic the dynamic behavior, you see? And now in the main function, we can really create the correct repository. So here I will now get rid of that one and add, in this case, the dyn heroes repository, because that is exactly what I need here. I want to have the trait object, and here you see that we are turning the real heroes repository into a trait object, so Axum will do dynamic method dispatching of our get, what was it called? Get by name functionality here. See? That is exactly what I wanted to do. And now I have dynamic method dispatching. That sounds good, right? That should do the trick. Let's give it a try and call cargo run in order to see whether it works. Okay, it compiled correctly. Go to requests. Let's call it for all the heroes. Works. Let's call it for Wonder Woman. Works. Let's call it for Spider-Man 404. See, everything worked correctly. We now have an API running where the data access layer is decoupled from the API. And now comes the beautiful stuff, because now we can make use of that to build real nice unit tests. Unit tests, and I consciously said unit tests because before we did integration tests. Now we do unit tests. So let me scroll down and let's get rid of these integration tests and replace them with the unit tests. And let me walk you through this code here. As I said, all the code is on GitHub, so if you can't follow along that fast, absolutely no problem. You can dive into more details later on by checking my GitHub repository, okay? Good, nice. We need one additional thing, our hero structure. Where is our hero structure? Here is our hero structure. Needs a bunch of auto-generated derived traits in order to work. So we need deserialize and a bunch of other things to make our unit tests work. But they are only implemented for testing here. See? So the derive macro is here conditionally bound to the test environment. So let's go down and take a look at the unit tests. Well, the request builder is exactly the same that we had before, so we don't need to talk about it. Now comes the important stuff. Here we have the method that should test the successful execution of getByName, but this time I am not using the heroes repository. Instead, I'm using the, let me zoom in, mock version, the mock object that was generated by the auto-mock macro of the mockall crate. So here we now have a mock implementation, and we can use an expectation. So we can say, I expect that someone will call getByName. I expect that this someone will pass in a certain filter. That will be the check whether the incoming parameter from the web API that you see here is correctly translated into the correct parameters for the data access layer here on the right-hand side, see? And then we are just returning a dummy heroes vector. It's just a vector of a default hero. That's not the case. I mean, we are just simulating anything. We can return whatever we want. Now the rest is very similar to what you have seen before, with one exception. Here we are again use the trait object, the dynamic method dispatching. So we are not just using the mock, but we are transferring. We are using it. We are changing it. We are making a trait object out of it. That is what I wanted to say. Then we can check the OK code and then check the content of the body. So we can easily take the dummy heroes that we created up here, and we can now do a detailed check of the JSON, of the generated JSON that we passed in or into the mock object. So you see, now we have a really nice function which only verifies whether the functionality of our handler function works properly. On the one hand side, here in red, we check whether the handler function passes on the parameter that it got out of the query string into the data access layer correctly. And on the other hand, we check here in green that the success code from the database was correctly translated into a success status code on the HTTP response message, and the JSON was also returned properly. Very nice. And now that we have the possibility to mock things, we can easily write a second test. And this second test does something a little bit differently, because in this case we are returning an error. So we can easily now simulate multiple different error scenarios which could happen in our database. It could happen that we didn't find the record. That will be the first line here. It could happen that there has been any kind of technical error with the database. And then we expect the API to correctly translate that into the status code not found and the status code internal server error. All we need to do is set up again the mock object, use the trait object with dynamic method dispatching here, provide that with Axum, with the with state method of Axum, and send the request. That's all we need to do. And at the end, we check whether the status is correct. Beautiful, isn't it? Nicely decoupled version. A nicely decoupled version of our app. We decoupled the data access layer from the handler function, and we can really nicely unit test the logic in our handler function. So let's give it a try, right? Let's do cargo test. Run it, compile it, and we get a lot of OK messages. That is a really nice end of a video. A lot of green checks here. As you can see, yes. That's exactly what we wanted to have, a lot of green OKs. So that is all I have for you. I hope you got an idea how you can solve the problem of decoupling your data access layer, your lower layers of your app from your API handler functions using trait objects and dynamic method dispatching with Axum 0.6 and the new shared state handling. That's all I have for you today. I hope you learned something from the video. And if you want to see the details, don't forget to check out the GitHub link, which I will add to the description of this video. Thank you very much. Enjoy the rest of your day and have a lot of fun with Rust and Axum.